Here is the cross sections for an isosceles right triangle. So remember, area of a triangle is half base times height. And then we integrate that to get the volume. Okay. Equilateral triangle, you have to be careful. Remember, we have to find the height by splitting that triangle into a 30, 60, 90. And so on the left side here, I kind of drew out, let me put that in purple actually. All right. So your height is square root of 3 over 2 times f of x minus g of x, because your base for that 30, 60, 90 triangle is half times f of x minus g of x. Okay. So there's a work for the area of the triangle, the equilateral triangle there. Okay. For the semicircle, your area is half times pi r squared, and your radius is half of f of x minus g of x. And so we end up with pi over 8 times f of x minus g of x squared, and then we integrate that. Okay. So those are formulas for known geometric figures. There will be times where you will not know the geometric figure, but they will give you a description. Okay. So I'm going to skip that question because that only applies to having geometric figures. Let's do this question. Find the volume of the solid formed whose cross-sections are the shapes indicated below. The cross-sections are perpendicular to the x-axis. Meaning, if we're doing equilateral, actually let me do I'll do a square. It's probably going to be the easiest. The cross-section for the square is going to be like this. Okay, so when it's smaller, those will be smaller. And if it's bigger, it'll be bigger, and so forth. Okay? So that's for the square, but let's do question A. If the cross sections are equilateral triangle, I know this is x cubed minus 4x. Okay. So again, one of the sides of that geometric figure is the difference between f of x and g of x. So if the cross sections are equilateral triangles, right? Now, if you have the information for equilateral triangle right there, you can go ahead and go straight to that volume formula. If not, you're going to have to be able to derive it. Okay. So volume is from A to B, top function minus the bottom function squared dx. Now, where are your limits of integration? Your limits of integration are from 0 to 2. Okay. Now, at this point, I'm going to go ahead and use a calculator, and that's fine. Okay. So this is volume. The volume is going to be about 8.641. 5. Okay. So again, go ahead and try B, C, and D, and I'll put up the answers in a bit, but let me go to E. Okay. The cross sections are rectangles. The height is twice the length of the base. Okay, so make sure you understand what this picture looks like. The height is twice the length of the base. Okay. So if the length of the base is f of x minus g of x, right? And that's going to be, this piece, right? F of x minus g of x. Your height will be twice as long, right? It's a shape of a rectangle. So something like this, right? Right, so your cross-section height is twice as long as the base. So this is my base, and my height would be twice as long, right? So your volume is the area, integral of the area. So integral from A to B, or in this case from 0 to 2, your base times height. So 2, your base times your height. Now I didn't put in the functions yet, dx. Okay. What was it, sine of pi x? Minus x cubed minus 4x squared dx. So since we're rectangles, the area is just base times height. So base times height. And this volume will be about 19.957, assuming my calculation is correct. Okay. So go ahead and try B, C, D, and E. I'm going to shut this off, and I'll finish it up in part 3, or I'll give you the answers in part 3.